Good morning, good evening, and good afternoon, folks. Welcome to this SONiC community meeting. For the 2023-05 release, we didn't fork the branch yet, so we want to leave more times to the community to finish the PR review while we are working on the SI SDK integration. So that's the one update from my side. Okay. So today's HLD comes from the broadcast, so I'm not sure who will present.
Hi, Yan Sang. Amitabha will present the PAC HRV from Broadcom today.
Okay, please go ahead. I think we can get started.
Yeah, sure. Thank you. This is Amitabha here. I'll just go ahead and share my screen. Just a sec. So is this, do you see my screen, everybody?
Not yet.
Not it. Not it. Oh, yeah.
Now
I can see. Yeah.
Right. Okay. So yeah, good morning, good evening. Thank you for joining. Welcome to this HLD review. Today we'll talk about port access control support in SONiC. At a very high level, this feature intends to prevent unauthorized access by clients to the services offered by the network. This is a one-liner of this feature. At the very heart of this feature is the IEEE 802.1x standard, which defines methods and mechanisms to essentially provide port-based network access control. Now, having said that, PAC as in this implementation uses 802.1x as one of the authentication mechanisms and goes ahead and adds a few more useful features over and above 802.1x. So having said that, I'll kind of jump directly to a topology diagram to give an idea of where this feature fits in. So the 802.1x standard defines a certain set of roles for this mechanism. One role being the authenticator, which is nothing but the network access controller, the SONiC switch in this case. And then we have what is called the supplicant, which are the clients or the devices that are trying to access the network via the network access controller. Another role is the authentication server. So here we have depicted the Radius server as a AAA server. AAA means authentication, accounting, and authorization. So Radius is the authentication server, and network is the network to which these clients are trying to get access to. So in the set of clients, you see two terminologies, 802.1x and MAB. So 802.1x are the clients like PCs and laptops, which implement the 802.1x supplicant state machines. So these are the aware clients. Having said that, we have added provisions for clients which do not support 802.1x, and we authenticate them using what is called the MAC authentication bypass. So in this, what really happens is the switch kind of uses the MAC address of the devices which are connected, and the switch mimics the authentication exchanges to the Radius server to authenticate this client. Okay, so that is about MAC authentication bypass. So having said that, I'll quickly jump to the function requirements. So PAC is supported on physical interfaces only, and PAC uses two authentication mechanisms for authentication of clients. One is the 802.1x, the other being the MAC authentication bypass. Both MAB and .1x can be enabled on a port together, and their relative order and priorities should be configurable. So essentially means, let's say you identify a client which is attempting to get into the network, you can decide to attempt .1x or MAB for the client first, and so on and so forth. And priority kind of tells that if the client is authenticated using one method, and if you see an indication of the other method, do you want to attempt an authentication with the other method and tear off the authentication from the method with which it is authenticated. So that's about the relative priority and order. Uh, PAC also implements a bunch of port modes. Now these are again defined in the .1x standard. Auto meaning authentication is enforced on the port, and clients have to authenticate themselves before any client traffic is allowed by the network access controller. Force authorized means the port is actually open. We don't enforce any authentication, and whatever devices are connected, their traffic is allowed. Force unauthorized is the exact reverse, where all traffic is blocked. We don't even attempt to authenticate the connected devices, and all traffic is just blocked. After that, I'll quickly talk about what we call as the host modes. So there are 3 host modes that are supported: multiple host mode, single host mode, and the multiple authentication mode. So the 822.1x standard actually defines what we implement as the multiple host mode, in which only one client is authenticated on a port, and after the client gets authenticated, the port is opened up for all the devices that are connected on the port. All the devices get access. So this is essentially, you authenticate the client and you open up the port. So that is what is defined in the .1x standard. Now over and above that, this implementation adds 2 more host modes. One wherein each device that is connected to a port has to authenticate itself independently. Single host mode is when only one host is allowed, and multiple host mode is when multiple devices which are connected have to authenticate on the port. Essentially, single host mode is a subset of multiple authentication mode, but we have these 2 authentication modes. Am I audible? Hello?
Yes, yes, we can
Yeah,
hear.
you are.
Sure. Thank you very much. Yeah. So these are about the host modes. Re-authentications of clients is supported. Essentially, re-authentication means you periodically verify client's credentials. Now, during re-authentication, the client traffic is not disrupted. So that's about re-authentication. And yeah, of course, .1x and map should be supported. Now, PAC needs to talk to a radius server. Now, then PAC essentially needs to implement the radius client functionality to be able to talk to a radius server. Now, we have an RFC that defines the interaction between .1x and radius. We use that RFC as the reference for interaction between .1x and radius. Yes. So there are various authentication methods that are supported. So when I said .1x or MAB, .1x actually uses the EAP as the authentication method. Now EAP actually is an encapsulation of other authentication methods internally. So EAP stands for Extensible Authentication Protocol. Internally, it can use methods like MD5, PAP, TLS, PAP or CHAP. So when we use .1x, the authentication endpoints are essentially the supplicant, the client and the radius server. The authenticator or the SONiC switch is actually a pass-through. It doesn't even look into the EAP frames to see, what authentication methods are in use. So it doesn't really matter to the authenticator. Whatever authentication methods the supplicant and the radius server negotiate amongst themselves, they are kind of automatically supported. For MAB, it's a little different because MAB clients are not .1x aware. So the authentication exchange essentially happens between the authenticator and the radius server. The authenticator mimics the supplicant role for MAB clients. The MAB client's MAC address is used as its username and passwords, and then the authenticator internally can use one of these methods for the actual authentication process. Which of these method is used is configurable. Once Radius authenticates a client successfully, again, the .1x Radius RFC has provisions for what are called authorization attributes. So these are kind of provisioning mechanisms for clients. Once a client is authenticated, we can associate a certain set of attributes for the provisioning. We support VLAN and the client session timeout attributes. Session timeout essentially means for how long the session should be active. And once the session times out, the termination action defines should you be re-authenticating the client, wherein during the authentication the traffic is not disturbed, or should you be cleaning away the client and have the client authenticate again. So we support this set of authorization attributes from the client. These three widely used radius servers are recommended for qualification: the free radius, Aruba ClearPass, and the Cisco ISE. Any questions so far?
So is only radius authentication supported, or you can configure local authentication?
Local is not supported. We don't have any plans to support local at this moment, because radius is the most widely used provisioning mechanism and most scalable. So we want to use radius, not local at this moment.
Okay.
Okay. Sure.
I had one small query. You did mention about this multiple host mode, right? And how actually the re-authentication functionality is realized in that particular mode.
Re-authentication is independent of the host mode. See, when a client is provisioned on the switch, essentially you have programmed the switch to allow the client's traffic on a certain VLAN, etc. Okay, so that continues to be as is. But when the re-authentication gets triggered via MAB or via .1x, the authentication process actually kicks off. And once the result of the authentication comes back, if it is success, you keep the client hardware parameters as is. But depends on, let's say during re-authentication, the VLAN changes, for all you know. VLAN changes, you have to reprogram the hardware. Okay, then of course you will see some traffic disruption. If the VLAN is the same, you don't need to reprogram the hardware. That is if the authentication is successful. The reauth is successful. If the reauth is a failure, then of course you tear away the client. So independent of MAB or .1x or even any of the host mode, re-authentication, that's how the re-authentication would work.
So re-authentication is basically binded to the device, although it is if it is 802.1x where wired connection or anything is there, so it is not binding to port, right? It is considering the supplicant.
It can be both ways. So I would have come to that, but since you asked, there are two ways of configuring re-authentication. One, of course, number one is you have to enable re-authentication on a port, and the next thing being the re-authentication timer. So the re-authentication timer can be picked from one of two places. Either you can configure it, that will be on the port, or for a particular client, it can be derived from the radius authorization attributes. Now, a combination of these two essentially determine the client re-authentication period. Session timeout is for how long the client is supposed to be active. That is fine. So once the session times out, if the session termination action is what is called radius, it essentially triggers a re-authentication. So combination of these two determines the re-authentication timer for a particular client. Now, for a particular client, do you pick it from the port or you pick it from the server? Even that is configurable.
Okay. There's no priority involved in that.
No, as of now, no. It is configured. Either you take it from the server, if configured so, or you take it from the port.
Okay. Is there any possibility of both being configured?
Well, as of now, we have not planned for, it is mutually exclusive, this or that. But if it really needs to be, if we really decide to, have one having a higher priority over the other, we can always think about that. I mean, yes, I understand that if a session termination action of radius comes from radius, and that can always have a higher priority, or if it doesn't come, you pick whatever is configured on the port. I understand your point. This can always be done.
Thank you.
Sure. So scalability wise, we support 16 authenticated clients per port and a maximum of 128 authenticated clients overall in the overall switch. These are not really hardware constraints, but constraints we have put in the software. So that's, yeah.
128 client is 128 MAB clients. I mean,
Anything, both
okay.
combined.
Both combined. Okay.
Yeah. Okay. So moving ahead, quick overview of the design. So as I was telling, this design, at the heart of the design is the 802.1x standard. Also, although I say that .1x is one of the authentication methods, but the terminologies like force author auto all kind of comes from the .1x standard. So SONiC already has a MACsec Docker which has a WPA supplicant code base, which has the .1x 2004 standard implemented. We have leveraged that particular implementation. All the other features, the enhancements that I've been speaking about are all built in addition to what is already present in the MACsec Docker. We don't have any plans to change the existing size spec, and that is not required at this moment.
Sure, sure. I asked you a question on the MACsec Docker. What role does it play? I saw you said the EAP is a pass to the radius. So, what does the MACsec Docker, role does it play in this design?
MACsec Docker is the authenticator. That is the Docker which would first see an EAP packet sent from this client, essentially the EAP start packet. So what we in the MACsec Docker, we use the host APD binary which listens to EAP packets. Now, as this client sends an EAP start, this guy kind of gets an indication that okay, I have a client indication. So thereafter, I mean, I'm kind of explaining the functionality, so which is fine, because for that particular client, you may have configured MAB as being a higher method in the order list. You may still want to do MAB. So then the host APD process, talks to PACD, and PACD sees what's the configuration, and depending upon which is the higher method, it would either, ask host APD back again to initiate the authentication or ask MAB to do the authentication. Let's say it asks host APD to do the authentication. So host APD then, talks back to the client asking for the client's credentials. So that particular endpoint, that particular authentication mechanisms are all built inside host APD. Now, once the .1x supplicant provides host APD with the credentials, these EAP packets are encapsulated in Radius messages by the Radius client, which is present in host APD, and they are sent to the Radius server. So when I said the authenticator is transparent, I essentially meant the contents of the EAP is what is opaque to the authenticator, but the authenticator still needs to take the EAP packets from the supplicant, encapsulate in Radius, send it to Radius, receive Radius packets, take the EAP packet out, and send the EAP packets to supplicant that way. So all those mechanisms are present in the host APD binary of the WPA supplicant code base in the MACsec Docker. And the
Thanks.
.1x authentic. Yeah. Okay.
Are we not binding a MACsec feature with the enact here? Are we by mandating
Yes.
to
Yes. That is correct. See, the MACsec Docker as such does much more than just MACsec. See, MACsec, as you see, the standard came in independently, but then the .1x standard also has mentions of how to integrate MACsec with 802.1x, and the WPA supplicant code base already has the .1x state machine, so it always makes sense to leverage what code base is available rather than making copies of it. Now, that being said, today the MACsec implementation uses the switch to implements the switch to switch MACsec, wherein .1x is not required. The keys are configured independently on both ends, and that is used for the traffic encryption. But when we go to host to switch MACsec, which essentially means you have a laptop or whichever device supports MACsec. So there, first the client is authenticated using .1x. Then the result of the .1x generates keys which are taken by the MACsec process, and then the MACsec starts. So essentially, MACsec is already closely linked to .1x. It is not really very far away from .1x. So both are essentially already linked.
Okay, so this is
So another one in terms of the psi attributes, I saw there's no change, but I think you still need to list what psi attribute you are going to use in this proposal.
Yes, I will
I mean,
get
it's
to
not.
that. Yes, yes, you're right. I mean, we will reuse whatever attributes are available today. Okay, so essentially we play with the port learning mode to prevent traffic from the clients. We use the learning mode drop, learning mode CPU trap, or learning mode hardware. Now these are all existing attributes. So what I really meant is no new attributes are required. Okay.
Yes, but I think it's better to list those attributes, in that section.
They
like
are
the
they
psi
are.
requirements.
Yes. Oh, okay. I understand. Okay, sure. I have listed them below, but I understand the question. I will list them above as well. I have mentioned them here actually. These are the notes, but I think I may as well mention them above. No issues. Yeah, sure. But these are the attributes that we use. Learning mode drop hardware CPU trap, and this is for the yeah. That's there is correct. Okay. Okay, moving ahead. So talking about the multiple, the various host modes that I was talking about, multiple hosts or the single host mode. The way we block traffic for clients, we play around with the ports learning mode. To start with, we set, as soon as we enable PAC on a port, we set the port learning mode to drop, or CPU trap is, MAB is enabled. So yeah, I'll get to that in a bit, but yeah, let me as well. So for .1x, the control packets are EAP. Okay, so for EAP packets, there are existing COP rules. So when a client sends an EAP start, these packets are trapped to CPU, and then authentication process starts. But for MAB, these clients are .1x unaware. They do not have EAP engine running. So they would just you connect a printer, you connect a phone or something, not a phone, connect a camera, video camera, something like that. So they would essentially maybe start with a DSCU packet. So for that, we have to configure the ports learning mode as CPU trap, which is all unknown source MAC packets we don't have an entry in the L2 table. These are trapped to CPU. And once they are trapped to CPU, PAC takes these packets and picks the MAC address and triggers MAB authentication for them. But essentially, the packets are not forwarded. So we play with these learning modes to prevent the client traffic. So for multiple host mode, once the client is authenticated, we change the ports learn mode to hardware, which essentially means the port gets opened up for any traffic for all the devices that are connected on the port. Single host and multiple authentication modes is a little different, because here we don't really open up the port for all the clients, but each client needs to authenticate itself independently. So the ports learn mode is set to CPU trap always, and once a client is authenticated, we install static FDB entries for each of these clients so that traffic from only these clients are allowed. A small mention here: once a packet is trapped to CPU, let's say for MAB, a packet gets trapped to CPU, uh, and the MAB authentication starts. So PAC already gets an indication that a certain device is connected. It doesn't need further packets from the client to be trapped to CPU. So what it does, it goes and installs a static FDB entry for the packet so that the uh, the device is not unknown anymore. So no packet is trapped to CPU anymore. But at the same time, the source destination discard bits are also set in the FDB entry so that traffic forwarding also does not happen. Once the
just
client is authenticated, this FD, sure.
Yeah, question. So since you're dropping packets to CPU,
Yes, these are
yeah,
rate limited. Yes.
yeah. So both the EOPL packet and
Yes.
customer packets will be rate limited.
Yes.
Okay.
So CPU flooding will not happen. Yeah.
Yeah.
Good point. Yeah, sure. So once,
Sorry,
Will
one
that
question
have a
here.
lifetime?
So I have one quick question on the static FTP entries, right?
Mhm.
So once you install the static FTP entries, like when it will be aged out, so do you have any aging timer?
for the static FDB entries are installed for both .1x and map clients. So one way of aging out is through the session timeout. If Radius sends a session timeout with the session termination action as default, once the session expires, the entry ages out. The entry is removed essentially.
Okay, so it will be
Yeah.
taken care by the control plane in that case.
Yes.
Sorry, one second, right? A related question. So what already explained, right, would happen for a authenticated MAC address, right? Let's say there's a MAC address that is not
Authenticated MAC
authenticated.
address. Yeah.
But let's say that's a MAC address that doesn't get authenticated, right? It's not in my whitelist of allowed MAC address list. Okay. Even in that case, I should install a static FTP entry to protect the CPU. But this will be in
No.
this
Hold
entry.
on. Yeah. Correct. See, this static FTP entry with the discard bit is only installed till the authentication is in process. Authentication attempt will not go on forever. The .1x will be attempted. There is a timeout within which, if the authentication does not happen, .1x will give up. MAP authentication will happen. Once MAP does not come back or MAP says authentication failure, so eventually there will be an authentication failure determined by one of these authentication methods. Once that indication comes from MAP or .1x to PAC is going to remove this entry. It will not just stay there forever. The client has to attempt authentication again.
So now it's not an allowed client, right? This is going to cause a lot of load on the CPU traffic, right? And it also could potentially be a denial of service attack. Okay.
Denial of service with CPU traffic is rate limited, right?
See, first, not now, right? This is going to rate limit even the normal valid packets as well, not just this packets, right? Typically, it's going to affect even the other normal valid clients as well. I'm just trying to see. I thought the other way would have been to, let's say a given MAC address comes in and we see it's not an allowed MAC address, right? We could have put the static FTP entry to prevent it from,
See, allowed and not allowed MAC addresses is like you don't even let the client authenticate, and you already decide that I don't allow. So that's a separate, intent altogether. Here, what we are saying is you let the client attempt authentication, and based on the result of the authentication, you decide what to do.
But this is not the right way actually. So when the first, MAC tries to learn in the bridge, so the learning itself should happen in CPU. You should not allow him to enter into forwarding database actually.
Forwarding database is there to prevent CPU flooding, as I told, and at the same time prevents the actual traffic forwarding.
Yeah, but then there will be gaps where the traffic will be forwarded actually without authentication.
Why will they be forwarded?
Yeah. So whenever the client tries to send packet with certain MAC address, we should not attempt to learn till it gets authenticated.
See, this learning is in the forward database is with a discard entry.
But we should not allow to do that. We should not allow to do that, right?
But why? I don't understand. Okay, maybe we can take it offline, but I don't understand the concern here. See, this entry is installed to prevent traffic forwarding as well as to prevent CPU flood. Okay. Otherwise, you keep attempting authentication and traffic will always keep coming to the CPU. PAC does not need to know further packets need to get further packets from the CPU.
Yeah, but thing is, the MAC address which are not authenticated, unnecessarily there could be a DOS attack and they'll flood the MAC table actually.
they will flood
I
the
think
MAC
I
space.
think maybe there's a gap here, right? So I think he mentioned that when he first insert the
Good
MAC
one.
address, it's like a discard, source, and that's the discard, right? So it has a FTP entry, but it's not really forwarding the traffic, if I understand correctly.
Correct. That's what
Right.
I mean as well. Yeah.
No, it's not just forwarding. It should not occupy the FDB space as well.
But what?
Well, I mean that I think yeah, then I think then we need to hear alternative solution, right? But on the high level, his solution is like, okay, in the authentication process, there is a FTP inserted with a discard. The basic action would be packet drop, right? So then the packet matching that will not be forwarded, while you can still trap those EAP packets, I guess, at this moment to continue authentication, but the normal traffic will be dropped, right? So only after
Correct.
the authentication is finished, then you will make that FTP entry as a forwarder.
Yeah, traffic will be dropped. I'm fine, but since it's occupying the FDB space, and if DOS attack is there, so FDB will be occupied, and there'll be a lot of flooding via switch actually.
Why will there be flooding? I'm sorry, I don't understand. Can you explain?
No. See, if there is a one
FDB
client
is
saying-
occupied. We have a max limit of 128 clients. So a
Correct.
maximum of 128 FDB entries will be occupied.
Yeah.
For a normal silicon, I think the FDB table depth is in like thousands, if I'm not wrong.
thousands. Yeah.
Correct. So
Yeah.
out of that, if we occupy 128 entries, first of all, that's a very small
Yeah.
number. Oh, hold on. Let me finish. That's a
Mhm.
small number. Number two, how will that lead to flooding? Can you please explain that? You have been saying that it will flood. It will flood.
Yeah,
flood.
because if
The
there
discard
are,
bit is set, by the way.
yeah, I agree. I'm not saying that, but if there is a DOS attack,
Yeah.
and unauthenticated back, clients are sending them,
Correct.
continuous packets with certain MAC address.
Correct.
So they occupy certain space in the FDB, right?
128 entries out of say 1000 entries minimum.
Normal
Maybe
learning
more.
process is also the same, right?
So no, I'm just trying to understand how will it cause flooding. You have still not answered my question.
Okay, since you're creating entry, so my assumption is you'll not allow them to create entry for that
No, the
unauthenticated.
entry is created with a discard bit.
I
still
agree.
haven't understood how it will lead to flooding.
Yeah, but the entry is occupying the resources of the.
Agreed.
Yeah.
1% of the
Okay.
resources.
Okay.
Agreed.
Yeah, exactly. So that is the catch here. See, discard entries are only till 128 clients, because beyond that we will not even attempt to authenticate the client,
Exactly.
isn't it? So you only have maximum of 128 entries in the
And they will be removed
FDB
as soon
entries.
as the authentication is denied if they are not in the whitelist. If they are in the
Yeah,
whitelist,
I
so
think
be
his
it.
concern is, Kamlesh, I think his concern is removal is not a problem, but they are occupying space. But you are
Fair enough.
essentially occupying only 128
Yeah, but I
entries,
still
isn't
don't
it?
understand
Beyond
his concern
122,
of
you are not
flooding.
even.
But anyways, I'll leave that.
No, I think his concern is occupy, FDB table with a DOS attack kind of a thing. I think I understand the question, but see, you only install 128 entries because you are limiting yourself to only 128 authenticated clients. You will only attempt 128 client authentication. You will never have more than 128 clients having FDB entries with discard bits. So you don't go over that. So you don't occupy more than 128.
And
I think that answers the question.
And 128 is fixed or it's configurable? I mean, based on the hardware resource.
No, it is fixed. Today it is fixed.
Okay.
So I think maybe I don't know if the concern is okay. So you have this 128 limit, but if there's a malicious client is continue to send various MAC for this authentication, then maybe prevents a real client to get authenticated.
Yeah.
Well,
Yeah,
how do you
that
how do you differentiate between real and malicious clients unless you attempt authentication?
Yeah, no.
That
I'm
can
just
always
saying
happen.
that there could, that
Yeah.
could be a concern,
Yeah.
but I don't know what would be the, whether there will be a better solution to solve that.
So
I'm just saying, yeah.
you can just forward unlearned packet to CPU and create
Which
static
is what
only. Yeah, but don't create entry for them is till you get those MAC address keys authenticated.
But
that will hog the CPU, right? Because if
No, we have rate limit, right? We have rate limit to
It's
control the
still hog
CPU.
it at 100 packets. We are actually limiting it down to 0 packets by installing the FTP entry with a
correct,
discard
only
packet.
one packet will come. The
That's
rest
it.
of the packets
After that,
will
your
not come
CPU
up,
is
right?
idle. And
Sorry.
even in that case, your 128 clients, if they come in with rogue or malicious MAC addresses, you will attempt authentication only for them, not for the valid 129th client. So you have still not solved the problem where you are trying to prevent authentication for a valid client. Because you can attempt authentication only for 128 clients at a given point of time.
No, that only in case of it if it exceeds the rate limit. Actually, I mean,
that's what I'm saying. If it's rate limits, then why even
no,
get
no,
100
no,
packets
no,
per
no, no.
CPU?
I'm not saying rate limit. So the clients are sending within the rate, but they are sending more than 128 packets actually at a time.
more than 128 packets, mean a single
Yeah,
client
because
sending more than 128
no, not
packets.
single client. There are 128 clients, more than 128 clients on a given port, and they're occupying your FTP space. So there could be 129 client, which is a valid client, which may not get chance to get account. I mean,
See,
authenticated.
In this case, right? I think let's say a client sends more than 128, right? Is either 1 or 2 packets only will come up, right? Rest will be blocked because we'll not get further packets till the client gets authenticated. So there is always room for the other clients which are 127, so that right they can come up, right? But if you don't install that hardware entry, there is a probability, right, that your 128 bunch, right, whatever you get, right, 100 packets are that could be from the single client. There is no way that others can get in.
So can I make a suggestion? I think either way, either trap to the CPU or adding this blacklist temporarily, could have pro and cons, right? So maybe can have some more offline discussion on those different approaches to see, right? So, but maybe we should continue, and I think there are some other topics in this design that we should also discuss, right? So.
Sure,
let's
thank you.
just
I
add
think
that a follow up for that. Okay.
One more question on an unrelated topic here, right? For the EAPL drops, right? We can use the existing SONiC COP configuration to rate limit. I'm just trying to understand how can the user tune the rate limiting for the unknown trapped packets, right? For all this authentication trap packets, how does the user configure the rate limit?
That we have not made it configurable as of this moment, but we can always take it up.
And which queue does it go to?
Yeah, mechanism. The question is mechanism. How you?
No, the question is the configuration, right? It goes to specific CPU queue. How does the user select which CPU queue it goes to, and how do we rate limit it, right? Today, the existing for EOPL, we can use the trap group mechanism, the COP table, right, to do that. How are you going to do for this particular trap packets?
I'll have to get back to you on that. We have to work on it.
Okay.
Okay. So moving
maybe
ahead,
Ravi, you can make a comment on that. I think that's a good point. Yeah. So.
Yeah, go on. I'll do that. Yeah.
Okay, I would request whatever I would anyway make a point about this, but if you could also add comments on the the HLD as well, that will help. Okay, moving on. Always associates clients to certain VLANs. Now, let's say a client is authenticated and the authentication is successful. Radius would assign a VLAN. Let's say Radius does not assign a VLAN to the client. In that case, the ports configured untagged VLAN is picked up to authorize the client. So all the traffic coming from the client is classified on that particular VLAN. The client can send tagged or untagged traffic. It will essentially send untagged because the client never knows about its VLAN. Ingress filtering is always enabled. So if the client sends tagged traffic with a different VLAN than what it is supposed to, then the traffic will be dropped. If Radius does send a VLAN for the client, in that case, what we'll do is we'll revert the port's untagged VLAN configuration, and we will use the Radius assigned VLAN, will operationally configure it on the port as its untagged VLAN configuration. This is an operational configuration. So all the traffic that comes from the client is now classified on this VLAN. Now, for multiple authentication modes, all the clients on the port are forced on this single VLAN. We do not support multiple VLANs for multiple clients on a single port. All clients are forced on the same VLAN. So if the second client happens to get assigned to a VLAN by radius, which is different from the first client, the authentication will be rejected. Now, having said this, let's say the port is operationally using an untagged VLAN, which is different from the configured VLAN. If PAC gets disabled on the port, or if the last client from the port goes away, the operational configuration is reversed and the configured untagged VLAN membership is reapplied on the port. So these, whatever I explained, are summarized in these points. During a warm boot, all the authentication client sessions are turned down and they will have to re-authenticate again. Okay.
So maybe can you, this
So
VLAN
that being said, I'll, sorry.
If the radius send the VLAN will put into the port into the VLAN mode, or I didn't get this part.
Yeah. See, if so let's say you have configured VLAN 10 as the port's untagged VLAN. Okay. So now the port is a member of VLAN 10 and the port's PVD is also VLAN 10. Now let's say you authenticate a client on the port and radius assigns VLAN 100 to the client. So what we do is we revert the port's configured VLAN membership. It stays in the config DB, but operationally we take the port out of VLAN 10 and we add the port on VLAN 100 and configure the PVD also on VLAN 100. So from that point onwards, any traffic that comes from the client by virtue of the PVD is assigned to VLAN 100, and that is what the client is provisioned on.
And in this design, you're not mentioned about flushing the MAC table actually. If it is,
I have not explicitly mentioned it, but you are right. Once you enable PAC, the L2 table is flushed. You're right.
okay.
So sorry, what is VLAN 10 in your example? Is the VLAN 10 the VLAN that used for authentication? VLAN 100 is used for
No, VLAN 10 is the original VLAN that's assigned to the port, but if the PAC is enabled, they will assign a different VLAN if the radius configuration is different. Yeah.
Oh, I see. They are both data traffic VLANs, so that they can move a port to a different VLAN.
Yes.
Okay, thanks. At what point do we move after authentication? Is that right?
Yes.
Or...
Yes. After authentication, see, when the radius sends the access accept packet, along with that packet, you get the VLAN information as well. At that point of time, if that VLAN happens to be different than the port's configured VLAN, then the configured VLAN is operationally taken out and the radius assigned VLAN is programmed to the hardware.
So there are two configurations happening at the same time, right? So there's a switch configuration, or is that the port on the switch that always in both VLANs?
No, single VLAN.
Okay, then there could be a risk, right? So when you configure the switch side VLAN, change the switch side VLAN configuration, and you let the port know that they need to change to a different. Oh, is that tagged or untagged?
Untagged.
Oh, so the client actually doesn't know.
The client doesn't need to know.
No, I mean in the authentication mode, right? So whatever in the config DB wouldn't really enforce. Is my understanding.
That is correct. Yeah, unless you want it to be that way. I mean, let's say in the config DB you have VLAN 10, which is the configured access VLAN of the port, and once a client is authenticated, it does not send a VLAN. So 10 would continue to be in the config DB as well as in the hardware, and 10 is actually used for the client. If Radius sends a different VLAN, then this configuration, this operational configuration change happens. Config DB remains as is forever. Did I answer the question?
So config DB remains VLAN 10, even if radius says you need to go to VLAN 100.
That is correct. That is correct. Because config DB is configuration, and VLAN 100 is the operational VLAN.
Okay, which DB contains the up-to-date authenticated VLAN information then?
State DB.
State DB, okay.
Yeah. Okay,
So
so
after
let
we
me
go to VLAN 100, so if some further, let's say you single home mode, if more authentication needs to happen, are those new authentication come up as if they are from VLAN 10 or from VLAN 100?
Yeah, so that's what I was saying. If further authentications happen on the same port, which has now provisioned a client on VLAN 100, subsequent clients, they have to be on VLAN 100. Radius has to send VLAN 100 for them. Otherwise, their authentication will be rejected, because as of this moment, we can only have one untagged VLAN configuration on a port.
Yes. Okay. Thank you.
Yeah.
I have a basic question around this. So all the current authentication, everything is now based on the radius server connectivity, right? So
Yes.
because of some network issue or downtime, if the connectivity between the switch and the radius server is not active, then what
Yes.
default behavior of the clients that are attempting or the already authenticated clients?
See, authenticated clients will stay as is unless a re-authentication triggers for them, because that is when you need to reach the radius server again.
Yeah.
For new clients trying to attempt authentication, if the radius server is not reachable, they cannot authenticate. That is what is that's the current behavior.
Okay. So even in the multi-host mode, where I believe like if one port is authenticated, any device can communicate. That in that mode also the same behavior applies.
I mean, in that mode, there is essentially only one authenticated
One
client.
authentication.
The rest.
Okay. So subsequent clients can access them. Okay.
Subsequent, they are essentially not authenticated clients. They are the tailgating clients. So they anyway continue to tailgate.
Okay.
Yeah.
So I got the default.
Yeah. So
and how you
we are
prevent
running
MAC
out of
move?
time. Just thinking which we do not prevent MAC move. See, when the hardware, okay, you are talking about okay, in which case can you be a little more specific?
I mean,
give me an example.
Simple case is currently MAC is authenticated on port 1, and that client moves to port 2.
That MAC shows up on the other port. Okay.
Yeah.
So if it shows up on the other port, that is still an unknown source MAC. That packet still gets tapped
Correct.
to CPU, and PAC comes to know about it. Then PAC sees that, okay, this device has moved. It is going to tear the client on the first port and attempt authentication on the second.
Yeah. Now you're answering my question, but is this explained in the design? So
it is not. I would add it. You're right.
I saw that actually. So that's what I'm asking.
Yeah. I'll add it. It's a valid point. Yeah.
So you have to tear down the earlier authenticated.
That is correct. That is correct. That is
With
correct.
a related question, right? Let's say this MAC moves to a port that is not under PAC. The MAC moves to some other port, right? Which is not under authentication, right? Not controlled by .1x. Now, what would happen in this scenario?
I mean, so we have, let's say, a static entry FDB installed. So, okay, let me ask this question. If there is a static L2 entry installed on a port, okay, and the packet shows up on some other port, what would the chip do? It's a static
Depends on the
entry.
chip, but it'll get dropped. Most of it, right?
It will get dropped. So
anyway,
that is what is
FDP
going
entry
to
will not get updated. You won't get a MAC mode notification.
Not get updated. Exactly. You're right. So if the packet will get dropped, and eventually the client on the first port is going to time out, right? Because it's not sending any packet anymore. So anyway, and this port, this particular MAC moves out of the purview of PAC because anyway it's connected to a port which is not PAC controlled.
But it won't get forwarded. That could be the behavior, right? Even though the MAC moved to some other port that is not in the purview of the PAC, it's still the packet will keep getting dropped.
It will keep getting dropped till the first client
Reauthentication or something, timeout happens, right?
Yes.
Okay.
Yes, that is correct. That is how it is.
Okay. Not sure it's desirable or not, but yeah, just
I think
something
that,
to think about.
It is momentarily, it will take, yeah, I mean, that is what is going to happen. Yes.
yeah. If the administrator deliberately moves, right, I think he would have probably done it with intention, right? So it will happen. If it is a attack, right? I think it will not work.
Okay, I'm not sure really it happens or not. For example, right? I'm just thinking I move out from a conference room, public room to, let's say I go to my authorized port, right? I go, let's say I plug out my laptop from my public room to from a conference room or guest room to my authorized port, right? Which doesn't happen to be under PAC. In those cases,
and those two ports are still part of the same switch. I mean,
yeah, they should be on the same switch for this issue to
yeah,
happen.
if
Exactly.
if the provisioning is like that, then yes, you will have to wait.
Yeah, but yeah,
If
I
that is how
agree.
it
Take
is
your point,
provisioned.
right? Yeah, it might not be the same switch in real life. Okay, I think that is a valid point.
It may not be the same switch
Yeah,
as well.
yeah,
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 these are
agree.
access switches, right? You go to
Yeah.
another room,
It
then
might be
that's
another
another
access
story.
switch. Yeah, okay, fine. That's fine.
Mm.
So regarding the learn modes, I see you have listed learn mode drop, hardware, and CPU trap. But there is a learn mode called FDP notification. Can that be used? Because it's a more efficient mode to introduce just for the .1x.
FDB notification, I have
Yeah.
not come across that. Can you explain it a bit for my benefit?
So yeah, if you see in the bridge.h, it says if an unknown packet comes, then it will create a new learn notification with the callback, but the MAC will not be learned. It will just create one notification instead of doing a trap, which traps all the packets to the CPU, right? So that's introduced only for the purpose of 8.2.1x. So if you can use that.
Yeah, that's what I was referring to. So in our HLD, we have used that actually.
Okay.
Sorry, team. So I think we only have 5 minutes left. So two things I want. One thing is like, you know, a similar HLD has been presented by Carpac Mini company. I think the HLD has been, the previous HLD has been added into today's HLD. So that's one thing I think, you know, team may need some discussion to see how to combine those two HLD. That's one. Second thing is like for this HLD, we need a reviewer. So I'm not sure. I already added 3 reviewers, but I'm not sure whether any other ones want to review this. Let's say this 2 HLD. So
yeah, I'm thinking. I'm
Yeah.
thinking like maybe, you know, since it's just there's just you know, too many good questions, I guess. So whether should we can we set up another time for the rest of the review? I guess people may still have some other questions, and it would be good if we can have
another time maybe is in July. So the
no, I mean maybe in a different time, right? So it doesn't have to be, you know, Tuesday. Can be any time that, you know.
Oh, that, yeah, that's fine. Yeah, I can pick up a time. So yeah.
Yeah, I mean, does is it sounds okay?
Yeah. So Guhan, Yansao. So then, you know, if that's the case, Yansao, why don't you find a time which is friendly to India,
and we can definitely attend and continue the discussion on this one. I think the plan that we have is after the formal full presentation of this HLD, I'm gonna set up for a subgroup meeting with Capgemini so that we can discuss and conclude how to converge between the two HLD and consolidate contribution in that way.
Yeah,
So
that's
then
fine.
why don't you go ahead and find a time, and then we can continue the rest of this HLD. Let's finish this, and then we move on to the next step.
Yeah, I think if people still have questions, please leave your comments into the HLD. I think that's another way to run the review. So yeah, I will book another time. Thank you, folks.
I have a very quick question. This FDB notification attribute, is this a standard SI attribute?
Yeah, it's there.
Yeah.
Yeah, it's a. I have added it in the comment, so it's a standard attribute.
Sure, thank you.
Yeah, thanks for that. Then
Okay,
with that,
so,
I guess Yanshao, you can take the time back, and we can continue next time.
Okay, I will book another time.
Thank you.
Thank you.
Thanks, everyone.
Thank you.
Thanks,
Thank you.
Abito.
Thank you.